Welcome back. Let us go through the question. Plot the corresponding reference circle for each of the following simple harmonic motions. Indicate the initial, that is t is equal to 0 position of the particle, the radius of the circle, and the angular speed of the rotating particle. For simplicity, the sense of rotation may be fixed to be anticlockwise in every case. X is in centimeter and t is in second. Now, in case of this, x equals minus 2 sine 3t plus pi by 3. So x equal to this. So this is also can be written. This also can be written as 2 cos 3t plus pi by 3 plus pi by 2, and this is equal to 2 cos 3t plus pi by 6. The initial position of the particle, that is x equal to 0, is when we put in the value of t as 0. So that is equal to 2 cos pi by 6, and if we and eventually the value of this is minus root 3 centimeter. So x at 0 is minus root 3 centimeter. The radius of the circle is the amplitude, that is 2 centimeter. The angular speed of the rotating particle is 3 radian per second. The initial phase is pi by 6, that is 150 degrees. So the reference circle for the given simple harmonic motion is this. See, the phi, that is pi by 6, is 150 degree, and this is a position, that is t when t is equal to 0, and we already got these values, that is minus root 3 and 2 centimeter. The next equation is x equals cos pi by 6 minus t. So likewise we get, as we have done in the previous case, we are doing the same thing here, and eventually we get x at position 0, t is equal to 0, equals to root 3 by 2 centimeter, and the radius of the circle, that is the amplitude, is 1 centimeter, and the angular speed of the rotating particle is 1 radian per second. Initial phase is minus pi by 6, that is minus 30 degree. So as it is minus 30 degree, so we need to point out this angle in this particular direction, and all the values are pointed out here. The next one is x equals 3 sine 2 pi t plus pi by 4. So likewise, so we need to we need to convert it to a particular equation, and so that we can compare that with the general equation, right? So here x becomes 3 cos 2 pi t plus 7 pi by 4, which is same as this. Now at t equals 0, phase is 7 pi by 4. Reference circle is shown as follows, and for the next one, x equals 2 cos pi t. So the initial position of the particle is this. So if we put in the value of t as 0 here, we get the x to be equal to 2 centimeter. That's the reason the radius of the circle, that is the amplitude, is 2 centimeter. Now the angular speed of the rotating particle is omega, that is equal to pi radian per second. Initial phase is 0 degree. So this is the reference circle for that particular equation.